Welcome back, everyone. In this lecture, we will talk about graph of functions. We define graph of a function as the set of points that are in the form of x and f of x, where the x coordinate or the first coordinate is the input and the second coordinate or the y coordinate would be the corresponding output, as x varies over the domain of f. So if you look at graph of a function, for any given point, for the given x coordinate x1, the y coordinate would be the corresponding output, that is f of x1. Let's practice this idea a little bit. In the first example, graph of a function is given. We would like to use the graph of this function to find f of 2, f of negative 3. So for the given input, we would like to decide what is the corresponding output. Or in part B, for the given output 0, we would like to decide what would be the input. Let's begin with part A. F of 2. That means I need to find a point on the graph of f where the x coordinate of that point is 2. The x coordinate of this point is 2. The corresponding y coordinate is 4. That means f of 2 is 4. F of negative 3. I need to find a point on the graph of f where the x coordinate is negative 3, negative 1, negative 2, negative 3. It's right on the x-axis. The y coordinate for this point is 0. That means f of negative 3 is 0. Now let's practice other way around. Let's find all values of x for which f of x is 0. Now the output is 0. The y coordinate is 0. The y coordinate is 0 here. The y coordinate is 0 here. And the y coordinate is 0 here. So x could be negative 3. Another value of x would be negative 1. And the third one seems like 3.3 or 3.4 approximately. There are 3 different values of x for which f of x becomes 0. Next, let's talk about how we decide if a given graph is a function or not. How did we define a function? A rule that assigns to each x exactly one f of x, and the part where we say exactly one f of x is very important. Exactly one. So now if I want to apply this to graph of a function, that means I need to make sure that for each x coordinate there is exactly one y coordinate assigned and no more. In order to check, I will use a test called the vertical line test. I will apply vertical lines to the graph of the function. If I can find a vertical line which intersects the graph of the function or the given graph at more than one point, then that is not a function. Let me apply the vertical line test in the following 3 graphs. In the first graph, any vertical line that I consider would intersect the graph at most at one point. This is a function. Why? Because for each x coordinate there is exactly one y coordinate. In the second graph, the circle, I can see that there is a vertical line that intersects the circle at two different points means that for one given x coordinate, I am finding two different y coordinates. This is not a function. In the third example, again, I can find a vertical line which intersects the graph at three different points. Means for one given x coordinate, I get three different y coordinates. This is not a function. So we apply the vertical line test to decide if a given graph is graph of a function or not. Let's apply it to the following example. In order to decide if this graph is graph of a function or not, I will apply the vertical line test. What I notice is that any vertical line that I consider intersects the graph of the given graph at most at one point. You may wonder about this point, -2. Let's talk about it. If you apply the vertical line test at this point, -2, you notice that this vertical line would intersect the graph at point -2 and 5, and that's it, because this other point is open. It is not included. So this vertical line is also intersecting this graph at most at one point. This graph passes the vertical line test, and therefore it is a function. You may wonder, is it okay that the graph of this function is, let's say, broken into two pieces? Yes. You may or may not remember any examples from high school. You may have been exposed to such examples or not, but the answer is yes, it's okay. Graph of a function does not have to be connected, in other words, continuous all the time, that there are some functions whose graph is discontinuous at some point, let's say informally broken. What's next? We would like to talk about how we can find the domain and the range of a function using the graph of the function. So, if you remember, we defined domain of the function as the set of all inputs. So in terms of graphing, that would be the set of all x coordinates. I need to put together the set of all x coordinates. Means for any given point on the graph of the function, I need to include the corresponding x coordinate and the corresponding x coordinate. It's as if you are finding the shadow of the graph of f on the x-axis. If you put together all these x coordinates, in this example, you will get a closed interval starting from A all the way to B. So in this example, domain will be closed A to closed B. What about the range? We define the range as the set of all outputs, which means set of all y coordinates. So for each given point on the graph of the function, you need to consider the corresponding y coordinate. If you put together the set of all y coordinates, you will get the range of the function. In this example, you will get the closed interval C to D. let's practice the idea, the following example. Graph of f is given. We want to find the domain and the range. So to find the domain, I need the set of all x coordinates. It's finding the shadow of this graph on the x-axis. Start point 1, and I need to include all these x coordinates all the way to this point, which is 9. Domain of this function is closed 1 to closed 9. Now range. I need to consider the set of all y coordinates. So starting from 1, I need to include all the y coordinates all the way to the highest point, this point. So the range of this function is closed 1 to closed 6. I suggest that you pause this video at this point and you spend a few minutes to think about the next 3 examples before you continue watching the video. It would be helpful if you think about the next 3 examples. First, we want to sketch graph of a function whose domain is closed 0 to 2 and the range is open 1 to 3. So let's start thinking. We are just thinking about this right now. What we get may or may not be correct. We will conclude and we will move on. So if I want the domain of this function to be closed 0 to 2, means I need the set of all the x coordinates to cover everything from 0 to 2 on the x-axis. And if I need the range to be open 1 to open 3, that means I need the set of all the y coordinates. Set of all the y coordinates to cover all the real numbers open 1 to open 3. Trying to satisfy these 2 conditions while we sketch graph of a function. I'd like to explore this a little bit. The examples that I will show here may or may not be correct, so we're going to think about this together. Let's think about this graph. So I'm going to think about maybe starting from 1, keeping 1 open, and maybe I'll consider just a line, a simple line all the way to this point. I'm wondering if this would satisfy all the given conditions or not. Let's check. So looking at the range of this function, range is open 1 to 3 is correct. It is exactly what we wanted. But if you think about the set of all x coordinates, here the set of all x coordinates is open 0 to open 2, and that's not what we wanted. We wanted close 0 to close 2. You may think, how about we close the endpoint? So how about close this point and close the other point? Well, let's check. Now the domain is correct. It's closed 0 to 2, and that's exactly what we wanted. But now the range is closed as well. It is closed 1 to 3, and that's not what we want. We would like open 1 to open 3 for range. So no, that's not quite it. We need to think about how we can satisfy both conditions at the same time. How about we keep the ends open so that we can satisfy the range and keep it open 1 to open 3. Now, in order to include 0 as x coordinate, instead of considering the point 0 and 1, I could consider a different point with a different y coordinate which is included within the range. How about the point 0 and 2? You may think, but it's broken. That's okay. It is okay for the graph of a function to be broken into pieces. So far I have this point. I have this line with open endpoints. Now I would also like to include x coordinate 2. But I do not want the y coordinate to be 3 because that will close this interval. So how about again a different y coordinate, say 2.5, or any other y coordinate you like as long as it's within the given range. Is this a function? Yes. It passes the vertical line test. Is the domain closed 0 to 2? Yes. Is the range open 1 to 3? Yes. Let's take a look at another example. Sketch graph of a function whose domain is closed 0 to 2. Range is 1. What does this mean? This is just a set of one element, and that is 1. Means the output can only be 1, nothing else. So we are trying to show graph of a function. The domain is closed 0 to 2, but the range is only 1. How could we satisfy such condition? A horizontal line would satisfy this condition. When you consider a horizontal line, like this one, for any given x coordinate, the y coordinate is always 1. The output is always 1. So the range is only 1. And the domain is closed 0 to close 2. Sketch graph of a function whose domain is closed 0 to 2. Range is 1 and 3. What is this? Again, it's a set of two different numbers, 1 and 3. Means the output is sometimes 1 and sometimes 3. We need to include both. So, how could we do this? We need to make sure that the graph we're providing is still a function, means that it passes the vertical line test while we're satisfying the two conditions, domain closed 0 to 2 and the range set of two numbers 1 and 3. Using the previous example, you may start thinking that it would be a good idea to include two horizontal lines. And yes, that is a good idea as long as these two horizontal lines do not overlap. Because if they do overlap, then the given graph is not a function. So how about we include 1 for some x coordinates. So let's say for all the x coordinates from 0 to 1, the output is going to be 1. And then for all the x coordinates from 1 to 2, the output will be 3. Is this a function? Yes. It passes the vertical line test. It is a function. Is domain everything from 0 to 2 closed? Yes. Is the range set of two numbers, 1 and 3? Yes. I encourage you to do some exercises from textbook, homework questions to practice graphing functions. We will come back to this topic every time we introduce a new type of function. We will revisit and we will talk about the graph of each of those type of functions. This is the end of our lecture.